All right, kiddos, this one I want to show you how to complete the square. It's kind of a technique that allows us to either solve quadratic, if we're trying to solve for x, if it's equal to 0, or kind of allow us to manipulate so that we can check out what the vertex might be. All right, so we're talking about quadratics. Let's get into this kind of messy process called completing the square. So let's look at it as a function, right? And here's the process here, and I'll kind of outline each step as I do it, right? So first note that that's not a square, right? It's not x plus the quantity something squared. It's not the quantity x plus 2 squared. It's not the quantity x plus 3 squared. So what I'm going to do is I'm going to work it so that it becomes a square on the right. So to do so, I want to first get rid of this plus 6. I call that the Klingon. Right? I want to get it out of the way. So I'm going to move it over here. And move it over there by subtracting 6 from both sides. And pops up here as minus 6. Okay. So what I've done now is I now have room to operate on the right-hand side. Right? And now what I'm going to do is I'm going to actually add a particular number that will indeed make this a square on the right. So now what I have to do is I have to take half, the special number that I do take and add to both sides, is half of my linear term, half of 2, which is 1. I square that and add that to both sides. Right? So I'm going to take half of 2, which is 1, square it, 1, and add that to both sides. Whoop. Sorry about that. So I'm going to add 1 to both sides, to the left and to the right. So now I have minus 5 on the right. Okay, so I just added 1 to both sides. I didn't really change it. I'm just kind of manipulating it. All right, added 1 to both sides. Okay, what that allowed me to do now is to write this right-hand side as the quantity x plus 1 squared, right, which is what I want. Right, so I now have completed the square. And so if I were rewrite on the right now, what I get is on the left f of x y minus 5 equals, and then on the right I'm going to get the quantity x plus 1 squared. Oh. And I want that to be squared, right? Okay, that was my goal. Okay, and so now I've expressed it as a square binomial. And now if I want to, I can add that 5 or kind of manipulate it further. So if I want to, I can add 5 to both sides. Basically put that number back here, right? And what we have here is we have a function. It's the same as the original function. It's just different, written a little bit differently, right? My original function was, of course, this. Right? So I bet you $1 million if you squared this out and add combined like terms, you get the same thing. Okay? So it's just rewriting a little different term, but this is more helpful. And as we'll learn, it's more helpful for a variety of reasons, one of which is because it gives us the vertex of this parabola, which would be negative 1, 5. Okay? Let's look at a messier case and see if we can hang. Okay? So this is messier because I have a non-1 leading coefficient. It's 3. Right? So I have to deal with that. But the first thing I suppose I can do is, well, you can either add the 4 to both sides, which I'll start by doing. I want to clear that Klingon. And now I have to divide everything by 3. Okay? So what I'm going to do on the left is I'm going to, just for sake of simplicity, I'm going to write on the left f of x plus 4, and that's the same thing as y plus 4, divided by 3. And when I divide the right by 3, this becomes x squared, and that becomes x over 3. Right? So I divide everything by 3, and now I have a, it looks messy. I'm going to put it back together later, but it looks messy, and it is messier. But now what I have is my leading coefficient, the quadratic coefficient, is now 1. Right, so I'm now in a good chance, a good place where I can actually complete the square. Right? Some people actually pull the 3 out and do it like that. I think this is easier. Okay. Now I'm going to proceed. Right. Now there's like a 1/3 out here. So x over 3 is the same thing as 1/3 x. Right. So to complete the square, you take half of the linear coefficient. The linear coefficient here is really 1/3. Half of that is 1/6. So I take half of 1/3, 1/6. I square that and add it to both sides. And I'm going to write it as 1/6 squared because that's going to help me remember what the heck. So it's 1/6 squared. I'm not going to write it as 1/36. I'm going to write it as 1/6 squared. Okay, because that's going to help me remember later. And if I add something to one side, I have to, of course, add it to the other side. Plus 1/6 squared. And I guess on the right, I can call it 1/36. Okay, and this is messy. It's about as messy as it's going to get. Okay, now what I can do is I wrote it on the right as the quantity 1/6 squared because now this ends up being, when I rewrite it, oops, start a new line. We have all this junk on the left side, and I'll clean that up in a hot second. But what I have on the right is, what I have on the right, why can't I get that? I want it right there. There we go. Is a nice square quadratic. So I have the usual mess on the left. I'm not going to do anything with that yet. I will. So that comes down. Come down. Oh, for the love. There we go. And what happens is on the right, that ends up being the quantity x plus 1/6 squared. Okay, so that's why I wrote that as such. X plus the quantity 1/6 squared. So on the right, I have the quantity x plus 1/6 squared. That's my square piece. And really what I need to do now is I got to clear all this mess up, right? This is a hot mess, right? So I guess one thing I can do is I can multiply everything by the least common, or the least common multiple of the denominators. So let's multiply everything by 36, right? So if I multiply this piece by 36, really a 12 comes up top. So I get 12, right, times, and that clears this fraction. So it's 12 times the quantity y plus 4, or f of x plus 4. Fair enough. And then when I multiply the 1/36th by 12, I get, by 36 rather, I get 1. Multiplying it by 36, not 12. And I multiply the right-hand side by 36, so a 36 also pops up here. Okay. Now this just kind of determines how quickly that quadratic is going to shoot up. It makes it thinner. Okay. Now I have to kind of isolate y, and it's just some algebra steps. It looks messy, but I'm getting there. So I'm going to subtract 1 from both sides. Get rid of this Klingon of 1. So the 1 comes over here. Okay, again, I'm trying to isolate y. I'm going to divide everything by 12. All right, so the 12 goes away. So that becomes a 3 here, and this becomes a 1/12 here, really. And then, of course, all I have to do is subtract 4, right? So I'm going to subtract 4. This just becomes y. And when I subtract 4 from negative 1/12, now 4 is 48/12. So I subtract from 1/12 another, negative 1/12 another 48/12. I get negative 49/12. Okay? Not the easiest way to break it down and put it back together, but that's the way I like to do it. Okay? Are there other ways? For sure. And again, now it's in vertex form, this function. The 3 just kind of makes it shoot up a little faster, makes it thinner if the 3 if there were 1. And my vertex is negative 1/6, negative 49/12. Okay? So that's about as messy as it will get. This first one was easier, the second one's messier. Okay? Hope this was helpful. We'll use it tomorrow. Bye-bye.